Rodney'i dinleyeceğiz. Rodney'le ben de 17 yıl evvel tanışmıştım. Cambridge'de onların organize ettiği 2 haftalık bir konferans serisi vardı. Çok kıymetli bir organizasyondu. Rodney her gün görebileceğimiz bir insan değil. Hani geçmişte böyle polimatlar vardır ya, çok farklı alanlarda derinlemesine bilgi sahibi olan. Rodney'in da astrofizik, ilahiyat ve matematik eğitimi var. Yani Oxbridge geleneğinde bu normal ama Türkiye'de biz pek denk gelmeyiz. Hani böyle bir astrofizikçi imam pek yoktur bizim şeyimizde. İnşallah olur tabii. Şimdi kendisi tasarım deliliyle ilgili bir sunum yapacak bize. You may start, sir.
Thank you very much indeed. Thank you for a wonderful welcome, wonderful hospitality, and for laying on this superb conference. Let me tell you where I'm going to go in this talk. I'm going to take a brief look at the Big Bang Theory. I'm going to describe the specialness of the Big Bang, the so-called fine-tuning. We've heard something about that. I thought I was being preempted, but I think I may have a little bit more to say. It's obviously a big topic, because we've heard it mentioned several times. So-called anthropic principle, out of which the idea of fine-tuning came. Some examples of it. The question, is there really anything to explain? Because there are certain philosophers who think there isn't. So what the explanations might be, what alternatives there might be for theism, really, and going through some recent developments in cosmology, how they have affected the issues, some problems for multiverses, which is the major idea out there, in contrast to theism, and so comparing the explanations. Now you may, well, I hope you do recognize the person on the right in that photograph. It's obviously Albert Einstein. The person on the left is a chap called Georges Lemaitre. He was a Belgian Roman Catholic priest and the father of the Big Bang Theory. Well, you have living proof that there's no contradiction between science and religion, and maybe we can go further than that. So Lemaitre solved Einstein's equations of general relativity, his theory of gravity for the universe as a whole. In 1927, he came up with an expanding universe solution. That expansion was observed in 1929 by Edwin Hubble. It was expansion from a large-sized Einstein universe, but in 1931, Lemaitre went on to formulate the theory which he called the primeval atom, whereby the universe had started highly compact and dense and had expanded from that state. Now, the Big Bang Theory is extremely well supported by evidence. The major evidence, of course, is the expansion. Now, that wasn't enough for a group of cosmologists in Cambridge, where I come from, who were atheists and hated the idea of the universe having a beginning in time. So what they came up with was an alternative called the steady state theory, whereby the universe expands, but the expansion is filled in by new matter created at just the right rate, which would be something like one atom created in a building the size of the Blue Mosque over a period of 100 years. Some phenomenally low rate of expansion. Now, that was around for a while, but along came the cosmic background radiation, which was the clinching piece of evidence in 1965. Georges Lemaitre heard about it on his deathbed. But it could not be explained on the steady state theory, and it was the clinching evidence for the Big Bang. There's quite a lot more evidence, but that was what did it at the time. That was discovered by these two chaps, Arno Penzias and Robert Wilson at Bell Telephone Laboratories in the USA. They thought they'd got bird droppings in their antenna, so it was said, but they were told by cosmologists that they had got the remnant radiation from the beginning of the universe. They got the Nobel Prize. Okay, so just a flavor of what the Big Bang tells us. The universe contains something like 100 to 200 billion galaxies. This is a typical one with 100 to 200 billion stars. That gives you a flavor of the size of the universe. That is a picture of the so-called Hubble Deep Field. The little blobs you're seeing there.
Rodney, sorry. Rodney?
Got it? Yeah,
Rodney.
Little blobs. Never mind. Individual galaxies. So that is... And those galaxies were formed something like when the universe was 5% of its present age of 13.8 billion years. Apologies. That is a typical supernova. The story goes that as galaxies form by condensations due to gravity, as the universe expands, stars form within the galaxies, and the earliest stars to form, the most heavy stars to form, explode as supernovae. They have cooked the elements of which you and I and our planet is made. The carbon, nitrogen, oxygen, all the elements are made inside stars. And then they are made available for the building of planets in subsequent generations of stars by the supernovae explosions. So it seems to me that cosmology raises two problems potentially for theology, two questions relating to it. There is the beginning of the universe, and that leads us to the Kalam cosmological argument and so on, which I'm not going to speak about, but it does also give the so-called fine-tuning. The universe needs to be set up in a very special way in order for everything to happen, this whole story to proceed, galaxies to form, stars to explode as supernovae, subsequent generations of stars to have planets and possibly life. So the fine-tuning relates to two kinds of condition, the initial conditions right back near the very, very beginning at the Big Bang, and the physical constants, the forces of nature, the four fundamental forces, their relative strengths, masses of the fundamental particles, and so on. Back in the late 60s, early 70s, this so-called anthropic principle was formulated, which drew attention to the constraints on the laws of nature required for us to exist. And originally due to a chap called Brandon Carter, I'm going to give the definitions in a classic book by John Barrow and Frank Tipler, which dates from 1986. And the anthropic principle comes in several forms. The word anthropic, of course, comes from the Greek anthropos, meaning man, human person, but that in itself is already a bit loaded. Paul Davies prefers the term biophilic because it's not necessarily human beings that the conditions allow to exist, but anything interesting at all, really, and certainly life in general rather than just human life. Now, the weak form of the principle says this: the observed values of all physical and cosmological quantities are not equally probable, but they take on values restricted by the requirement that there exist sites where carbon-based life can evolve, and by the requirement that the universe be old enough for it already to have done so. Now, This is essentially saying we can only measure the values of these physical and cosmological quantities that are compatible with our own existence. Indeed. The probabilities concerned there are not, of course, a priori probabilities before you even think about there being life. They're really conditional probabilities given that life exists. Well, they have to take values within these very narrow ranges. But the a priori values, well, they can be drawn from, theoretically, from much, much larger ranges. Now, the strong form of the principle says simply that the universe must have those properties which allow life to develop within it at some stage in its history. Well, it's that word must which is tricky here. Well, it must, given that we exist, and that will really take you back to the weak principle. But it's almost saying that life must exist. And in a way, that moves us closer to what has, in Barrow and Tipler, is called the participatory anthropic principle. Observers are necessary to bring the universe into being. Well, are they? That takes us into the realm of the idea that we as humans create the back history of the universe, the whole history of the universe, simply by observing it. It's a way of interpreting quantum theory. It's had a bit of a run for its money with various cosmologists, some rather famous ones, including Fred Hoyle, John Wheeler, and most recently, posthumously, with Stephen Hawking. Personally, I don't think it makes sense. We pre-exist, well, the universe pre-exists our existence. We evolve out of the matter that's already there. So I think the notion of the anthropic principle is not really all that helpful. It's better to focus simply on the fine-tuning. So let me give you some examples. The mean density of stuff in the universe has to be what it was to 1 part in 10 to the power 15, just 1 second after the Big Bang. Indeed, the universe is sitting on a knife edge between expanding forever and eventually recollapsing. And it needs to be on this knife edge. If the universe were expanding too fast, then the expansion would run away with itself and gravity would not be powerful enough to create galaxies in the instabilities that there are. If the universe were overdensed by more than this tiny amount, then the gravity would pull it back much too fast for interesting things to happen. And so it needs to be poised on this knife edge. And you can theoretically take this number back to the first 10 to the minus 43 seconds when the balance is much, much more tight, even one part in 10 to the power 60. As was mentioned earlier, some of these examples are not constant. This density evolves with time. This critical value of the density evolves with time. Second example, the weak nuclear force responsible for radioactive decay and the gravitational force need to be balanced in a very particular way. They're related to each other in a very particular way. If you take the standard non-dimensional units, then the gravitational force is something like 10 to the power 4, is the weak nuclear force to the power 4. And if you were to tweak this ever so slightly, then one disaster would be that all the hydrogen in the early universe would turn into helium. There would then be no prospect of water. We heard about the importance of water earlier on, subsequently in the universe. And if it goes the other way, then the supernovae will not go right, or it's highly problematic if that is just out by a small amount. Now, there's the strength of gravity itself. Well, it can be a bit higher than it is. Maybe a factor of 3,000, say, which sounds like a big factor. Maybe not fine-tuning. It is fine-tuning because of what the range potentially could be, maybe 10 to the power 40 times the actual value. The thing is, if you were to raise the value of the strength of gravity, it would become eventually impossible for there to be life. We would sort of start to get crushed on this planet. Maybe you could think of moving to other planets that are smaller, but eventually the planets get so tiny there's no prospect of them being able to sustain an ecosystem. So there's a real limit. But as I say, in principle, that value could be 10 to the 40 times the actual value. And so that would give you, that would give you a probability of 3 times 10 to the minus 37. Tiny, tiny probability of it being in just the right range. Now, another example. Yes, there's an excess of matter over antimatter in the very early universe. Matter and antimatter are created in the quantum vacuum and they annihilate. There needs to be just an excess in order for there to be the stuff of which we're made. And there is a tiny excess of something like 1 part in 10 to the 9. Then there is, and this is, I think, a most interesting example. It concerns how carbon and oxygen necessary for life are manufactured inside stars. And carbon is made by crashing 3 helium nuclei together and making them stick. It's extremely difficult to get that reaction to go because the intermediate element, beryllium, with 2 helium nuclei, lasts for a tiny fraction of a second, 10 to the minus 17 of a second, something like that. Okay. So it's extremely difficult to make that happen. And interestingly enough, there was a famous cosmologist called Sir Fred Hoyle who discovered an effect in the carbon atom that called a resonance that made that reaction go fast, so we really would get carbon made inside the cores of stars. And I'll just hold. Oops, so I'm going the wrong way again. So Fred Hoyle also needed it to be the case that not all the carbon was converted to helium, to oxygen. So we need oxygen as well. That's made from adding an extra helium nucleus on. So you get 4 helium nuclei making the nitrogen. Now, making the oxygen. Sorry, let me get this right. You need both carbon and oxygen. Now, Hoyle, when he discovered these coincidences, seemingly, this militant atheist who had broadcast on the BBC saying how, the science has done away with God, absolutely no need to believe in God, and so on. Belief in God is just an illusion. Anyway, when he made these discoveries, he did an awful lot of the work on this nucleosynthesis inside stars. He came up with this remark: a super intellect has monkeyed with physics as well as with chemistry and biology, and there are no blind forces worth speaking about in nature. The universe is a put-up job, he said. And if it weren't a matter, he said, of there being perhaps a religious side to this argument, then cosmologists would be convinced that it was a put-up job. But it would, he didn't want to give food to theists. And of course, he used this word super intellect. He couldn't quite bring himself to use the word God. But what is a super intellect? A super mind behind the universe and its laws. Now, Paul Davies is a great cosmologist, and he describes this so-called fine-tuning in this way: like the porridge in the tale of Goldilocks and the Three Bears, the universe seems to be just right for life in so many intriguing ways. He's very taken with this whole idea. He can't quite bring himself to believe in God either, but he sees that there's an argument there. Now, so some cosmologists and physicists, as I say, have asked the question, is there really anything to explain? And this is one, Richard Feynman, very, very great physicist. He described the situation a bit like this. Suppose a car with the number plate ARW357 turns up in the car park of my laboratory. How utterly improbable, he says. That car with that number, wow. And of course, he's making the point that any car with any number would be just as improbable. Just because it's improbable, it doesn't really mean anything. It doesn't require any special explanation for that particular car to turn up, because some car, would turn up. There is a set of cars out there, and they're with all sorts of number plates. So it doesn't really matter. On the other hand, there are arguments why there really is something to be explained. Richard, who's here, came up with this idea of the madman who's kidnapped you, ties you up to a machine, and this machine shuffles cards, and unless they keep coming out, with 10 aces and 10 aces and 10 aces, the machine explodes, and lo and behold, you're not there anymore. In fact, it keeps coming up with all these aces. Well, is there something to explain? Is that just the fact that getting an ace is probability 1 in whatever it is, 1 in 10 to the 60 or something? Well, I'll come to that in a minute. Extremely low, that it keeps coming up. Is it just a question of probability, or is there something to explain? Well, it looks like there is something to explain in that instance. And there's a similar example from John Leslie of the firing squad. There you are, blindfolded, you're about to be shot, and lo and behold, bang, bang, bang, bang, bang, and someone comes, takes the blindfold off, you're still alive. Well, is there anything to explain? Just accident, just a question of probability? Or did they deliberately fire over your head? Did they deliberately misfire? Was the madman with the machine deliberately torturing you by keep bringing up the aces? Something is going on. Or are there maybe many firing squads around lots and lots of different universes, and in a very small number, the victim survives. Well, and you are the survivor. Well, I don't think that particularly explains why it would be me who survived, but that's a kind of issue we're going to be coming to. Suppose I just simply shuffle a pack of cards in front of you and I deal this kind of perfect hand. Do you think, well, that's got a probability, I think, of 1 in 10 to the 60. That's that kind of number. Or do you think, well, maybe I'm a card sharp. Maybe I've fixed it to come out that way somehow. And I think that would be far more likely, because that's a meaningful, really meaningful hand. Now, and I think that's the difference really between any old universe and the universe we're in. The universe that we're in is rich with special meaning. It is not any old random universe. And Paul Davies says, my own inclination is to suppose that qualities such as ingenuity, economy, beauty, and so on have a genuine transcendent reality. They are not merely the product of human experience, and that these qualities are reflected in the structure of the natural world. These are genuine qualities that are out there. So, what possible explanations are there? There is, I think, what seems to many of us to be the natural explanation. The universe was set up this way by God because God intended there to be intelligent creatures arise in it one day who would be able to relate to him, to worship him, to be guided by him, to live their lives in the way he intended. But then what are the alternative explanations if you are an atheist? And it seems to me that there are two main explanations. The one is, well, maybe you're wrong. Maybe these constants can't vary, or these laws of nature can't vary. Maybe there will be an ultimate theory of everything that comes along, calculates all the constants and so on, and it's the only self-consistent set of laws. That idea, I think, is, I would say, highly implausible, you see, if all the constants were eventually calculated by some theory, well, there would still be the question, well, why does this set of laws, this remarkable set of laws with these properties that it brings about life, why is that set of laws instantiated? You've shifted up the problem from the constants themselves into the laws. You would have to go the next step too then to say, well, only this set of laws is mathematically or physically coherent. Well, it certainly doesn't seem like that. Mathematicians can play with laws. We can imagine, and wouldn't it be also incredibly surprising if the only set of constants that there were, or the only set of laws that there were, gave rise to life? I mean, we can imagine a lifeless universe. We can imagine a universe in which there are just a few rocks or particles free-floating in an otherwise empty space. There seems nothing at all incoherent about that. And it's the idea of well, let me go to the next stage, and that is the direct opposite, and this really is the popular one today, that there might be a multiverse, usually an infinite set of universes in which, okay, for the laws of our universe, all the constants take the values they can, but in different universes. And by extension, there may be universes with different sets of laws. The logical kind of end point of this is what Max Tegmark calls his level 4 multiverse, in which all mathematical structures have physical existence. Now, I think philosophers think that these ideas are barely coherent. I mean, there will be contradictions between what universes actually exist and the laws and so on. This is a universe in which I come along and give a lecture in Istanbul. There'll be another universe in which a copy of me, in which you could say in which I make a different decision and decide to have an easy life, just stay at home, lie in bed, or, it raises issues, which again I'll come to, of human identity. There will be, I certainly can't both give a th in Istanbul and stay at home. Maybe some copy of me could do that. But both seem to be possibilities, do they not? I could have decided to stay at home. That would have been another possible universe. I literally couldn't do both. So it raises certain issues of that kind. And it takes you way beyond what science can tell us. Okay, developments over, so for atheistic strategy 1, isn't it an incredible puzzle why the only set of laws gives rise to life? And for atheistic strategy 2, well, why this multiverse as opposed to another? There's still a choice to be made. You need a multiverse generator, and there are lots of different ways of getting multiverses, even of getting multiverses containing infinitely many members. You can never complete a multiverse. And then you end up with the Max Tegmark ultimate all mathematical structures exist. Recent developments in cosmology over the last few decades. Now there's a theory due to Alan Guth in which inflation happens in the first 10 to the minus 32 seconds. The universe expands incredibly fast. And that was meant to solve some of the fine-tunings. It drives the universe to uniformity so that the expansion rate is just right, the mean density is just right. It's on this kind of boundary. Problem is, though, of course, inflation needed to be fine-tuned. It needed to end just at the right time, and so on. And so today you have what are multiverse versions of inflation, chaotic inflation. Inflation happens at different rates, different parts of the infinite space-time, and universes bubble up out of other universes, creating a multiverse version. Here is a chap called Leonard Susskind, who is the father of string theory. String theory was, if you like, an example of strategy 1. It was supposed to calculate all the numbers, all the constants. It comprises little tiny strings, matted little strings that vibrate in different ways that give rise to the different particles. It's a candidate for the theory that describes gravity and quantum theory together. But of course, must be getting on for 50 years, it's made no predictions. And so there's been a move to the so-called landscape of string theory, which is a multiverse version of string theory. Maybe 10 to the power 500 solutions, all of which are instantiated in different universes. Now, this is one of many areas in cosmology today where speculation has taken over. There's wonderful, incredible work on the observational side, but there is also theoretical work, there's good stuff, but, and for lay people in particular, it's difficult to tell if you read a popular book on cosmology where the well-established theory, you're passing from that to the more speculative stuff. And string theory, if it's true, it would apply to the first 10 to the minus 43 seconds, tiny, tiny fraction of a second from the beginning. And Lev Landau has been mentioned today, famously said, cosmologists are often in error but seldom in doubt. I think he's been vindicated in many ways because there are a number of different candidate theories out there, all sort of competing. Now, let me go through a few problems for the multiverse idea. Well, I've mentioned the physics is speculative. The Large Hadron Collider in CERN, where the Higgs boson was discovered, that can take you back to maybe the first 10 to the minus 10 of a second from the origin, the period when that particle would have been created. But 10 to the minus 32 seconds for inflation, 10 to the minus 43 seconds, those are very, very early times, and we certainly would never be able to mimic those times and create the energy. We can't do it that way, that's for sure. in a super collider. There is a problem about infinities I've hinted at. There are all sorts of paradoxes to do with infinity, particularly as, if there are infinitely many things, infinitely many universes. There's the problem of Hilbert's Hotel, infinitely many rooms, they're all full, some new guest comes along and he just shuffles the guests along. Person in room 2 goes, room 1 goes to room 2, one in room 2 to room 4, one in room 3 to room 6, etc. Infinitely many new rooms, infinitely many new rooms available for infinitely many new guests. There are paradoxes that arise. I've mentioned really the question of human identity, the identical me deciding to stay at home and lie in bed rather than take the journey to Istanbul. And what I'd have missed out on is incredible, but if I'd done that, but be that it may, possibility. It's not a simple hypothesis, this whole idea of a multiverse with infinitely many entities, a choice to be made between multiverses. Compared with one physical universe, it's highly complex, and so if one physical universe is improbable, this a priori would be highly improbable. And it goes against the grain of the way scientists formulate theories. They take the simplest kind of criteria that Professor Swinburne was talking about among competing theories. Then there is this problem arises of lack of predictability. You get some strange feature in your laboratory and you think, well, maybe we're in a universe where that just kind of happens. There are, anything that can happen somewhere, sometime in some universe. It kind of gives you a multiverse of the gaps. We sometimes hear about God of the gaps, where God is introduced to explain things that science explains. Well, there's a possible multiverse of the gaps arising now, rather than doing normal science. The cosmological constant, that was mentioned and called dark energy earlier on. The problem with that one is that physicists think they know what it is. They calculate it, and they get an answer that is 10 to the power 120 times too big. And as was said, if it was anything more than, very small amount bigger than it is, then we couldn't exist. If it suddenly took that value now, then everything in this room would fly apart to opposite ends of the universe before I could click my fingers. If it was anything like the calculated value, the result would be utterly horrific. Fine-tuning still seems to be required to get a universe that is infinite in extent anyway, to have different regions where these different things happen. And most of the kinds of model multiverses are in fact different regions of an overarching space-time. If the mean density of stuff, though, were were more than the critical value, well, we would be in a finite-sized universe. Rather than infinite one. And in fact, it's very difficult to tell what is the case because we are at this cutting edge. Scientifically, it's very difficult to tell whether we're in a finite-sized universe or one that is infinite in extent. Then there is the amount of order in the universe. This, I think, is one of the critical ones. It was mentioned this morning that Roger Penrose came up with this figure of as it were, the creator. Cosmologists often use terms like creator, God, etc., metaphorically for them. Anyway, had 10 to the power 123 possible configurations to choose from, only one of which would have the order and structure that ours does. Okay. Now, that's an incredibly, infinitesimally small probability of the universe having the order and structure as does. But the problem goes a bit further than that. In a multiverse, say, if there were more than 10 to the 10 to the 123 universes, we're an infinite universe, infinite space, infinite multiverse, then universes like that would exist. But there's a further problem. They'd be incredibly rare, but they would exist. There's a further problem. To get life, to get us, you would only need the order of, say, a single solar system. Single galaxy would be a bit far too much. You would only need the order of, say, a single solar system. Now, that would have a kind of equivalent probability of existing of 1 in 10 to the 10 to the 60. Yeah, terribly, terribly tiny. But the point is that that would vastly outnumber, vastly outnumber the universes that are ordered and structured as ours is. It's like the monkey sitting at a typewriter for eons and eons on end, eventually coming up with to be or not to be, that is the question, and saying, okay, when the monkey gets there, that's equivalent to there being a universe with life. Okay, that would exist. But our universe isn't that one. Ours is more like the complete works of Shakespeare. We would be vastly, vastly more likely to end up in a universe that's more like the one line from Hamlet. I'm running out, I'm sure.
5 minutes left.
5 minutes, yeah, great. Just enough time, I think. So, there's also the issue of fake universes. And this is taken seriously by various cosmologists like Paul Davies, John Barrow, the philosopher Nick Bostrom. As soon as you go down the multiverse road, sooner or later there'll be civilizations that are clever enough to make universes, to make simulations of universes, which are far, far easier to make than real universes. So the upshot is then we would end up being far, far more likely to end up in a simulation of a universe than in a real one. As I say, that one is taken seriously. It'd be more likely to be in something like the Matrix than in a real universe. Okay, so I haven't really gone into the idea of ultimate explanation and the Kalam argument, or argument for the existence of a unit, why there is a universe at all, but God provides the explanation for that. Theism provides a simple explanation for what there is, and for there being a universe, and for it being fine-tuned. And, God freely chose to create this particular universe, intending that it produce intelligent creatures. He could have produced a multiverse if he'd wanted. He could have done it that way. But this would be my view, that he chose to create this particular one. God would be much more likely to produce a universe that has all the order and structure as does, as far as we can see, with 10 to the 22, 10 to the 24 galaxies, stars and so on, in 10 to the 22 stars in 10 to the 22 galaxies. Okay, I will end then with a quote from the chap I started with, Georges Lemaitre, who... And incidentally, both I and my wife, who's here, that others have met, are priests in the Church of England. We rather identify with this remark of Georges Lemaitre. There were two ways of arriving at the truth. I decided to follow them both. Certainly one can follow a religious vocation. One can be a Christian, a Muslim, and be a scientist with absolute integrity. And indeed, I think I've shown, and others today, that science may even point us towards God. Thank you.
Evet, Dr. Oldur'a da teşekkür ediyoruz. Sorumuz var mı?
Thank you for this amazing presentation. Me and my friends We're so motivated to come here and listen your presentation, so thank you for that. I would like to ask that did miracles happened based on the rules of physics? For example, the splitting of the ocean by the Prophet Musa, or is there any other explanation? Thank you.
That's a very interesting question. I wrote a number of articles. I wrote an article a number of years ago on the issue of miracles in response to David Hume. And this was in the British Journal for Philosophy of Science. It's one of the things I'm really most pleased about, because of course that's secular, it's where Karl Popper and people published their work. David Hume is generally thought to have defeated the whole idea of miracles, but he didn't really understand probability. Testimony is what counts for miracles, and testimony can mount up, and it can theoretically make, if there's a lot of testimony to a miracle, it can overcome a natural skepticism, perhaps due to the way we think that matter really doesn't behave that way. And of course, you have to be prepared even in science for surprises. Otherwise, you'll be stuck, you find contradictions to the laws that you think are universal laws, such as the law of gravity. And Einstein could explain something that was inexplicable on the laws as they were known at the time. So yes, and of course I think God can act outside the laws of nature. I think the whole argument about miracles is strengthened, of course, if you already have good reason for believing that there's a God, because the God who created the laws of nature is the one who can transcend those laws. We often don't think of, we think of him transcending rather than contradicting his laws, doing something that is beyond what the laws would normally describe. So yes, that can happen with Moses and the crossing of the Red Sea. Interestingly enough, we have a very fine scientist in Cambridge called Colin Humphreys, who has done a lot of work on this sort of thing. He's a materials scientist by trade, he's a fellow of the Royal Society, very distinguished. And he's done a lot of work on the miracles of Exodus. And he rather regards it as a miracle of timing, because, of course, storms and things can happen, winds can happen, and they can blow in different directions. There might be some natural physical explanation, but, God told Moses, and Moses spoke the words, and it happened just at his word. So there has to be something special going on.
Yeah, thank you. And also we are very happy to see you in the YouTube channel of Religious Answers. And we really like your videos. Thank you so much.
That's very kind. Thank you.
We have a question over here. Thank you. Sir, here I'm. Do you think that Occam's razor is able to disprove multiple universes?
I think I wouldn't go so far as to say disprove. I think when it's a choice of theories, you do not multiply entities without need. And I think it is a violation of Occam's razor to do that, but I wouldn't put it as an absolute, that it absolutely disproves. And indeed, I think, as with Professor Swinburne, I'm regarding this kind of argument from fine-tuning and other arguments from more of an inductive kind of nature than a deductive kind of nature, and that might compare with some of what we've heard earlier on too, which is would be an interesting thing to follow up at some point. Not absolute proofs, but making, as I would see the fine-tuning, making the idea of God highly probable.
I agree, thank you.
First of all, I want to thank you again for your presentation. It was really beneficial. So my question is that naturalistic idea asserts that fine-tuned argument is not valid because through natural selection, many species burned out through time. So we cannot really focus on how the universe was made. So we should focus on how species died out throughout the history. So I wonder, what do you think about that? And I wonder if you think this could be a problem for fine-tuned arguments. Thank you.
I don't really see it as a problem. Indeed, the story of extinction is a story which makes room for us, if you like. I mean, it's interesting that the dinosaurs famously were wiped out by the collision of a giant meteorite or asteroid or something. And that created space for modern mammals and for ourselves. If there's a problem, then it's a problem that is possibly the most serious problem for religious belief anyway, which is the problem of suffering and pain. There would be a lot of pain in the animal world prior to us arriving, and of course there's the problem of pain for humans themselves. I tend to take the view that for me to be here, it's just about, this process is just about the only process that could be used to make me. I am who I am because my parents fell in love, got married and had me. Ditto before them and before them and before them. And you can go back millennia and millennia and millennia. And I have the characteristics I do because I'm human, and I think I have freedom. How does it arise that we are free creatures able to exercise free will? We are not determined. And I think that has some reflection in the way and the processes of the universe itself, of the evolutionary process itself, which has chance and interplayed with necessity, as John Polkinghorne would have put it, and if you like, a shadow side. The intention of God is ultimately to make free, rational creatures who are able to exercise free will and do good, as others have said. But, of course, that gives us also the potential to do evil. It is a massive, massive responsibility. As a Christian, I read the Old Testament, and I read that humans are made in the image of God. So that gives us tremendous power. It gives us power to understand the universe. Our being made in God's image explains how come we can understand the universe. It also explains our capacity to do massive good and to have freedom. But yeah, there is a problem. I don't think evolution as such is a problem for the fine-tuning. I mean, the fine-tuning really gives you the material and so on to make life, to make carbon-based life on a planet, and for that to get going. And it gives you the elements that have the properties they do, like water, and the molecules that are built up like water, and so on. The carbon is probably the only atom that can build long-chain molecules, DNA, and so on in the way that it does. Fine-tuning gives you all of that. But the fact that there are extinctions, I don't think negates that in any way. It's part of the story, part of the whole cosmic story, and perhaps inevitable. There are bacteria. There are good bacteria. We need bacteria. Most of our, we've got, I don't know how many bacteria in our bodies. There are good ones. There are bad ones that do us harm. But it's a kind of package deal that we have with life in the way that it's made. I've touched on the problem of suffering. That's possibly for a whole other symposium, really. But I thought I would mention it in response to that question, and I'm still struggling with it.
Son bir soru alalım arkadaşlar.
Merhaba Mr. Rodney. Bize bu güzel konuşma yaptığınız için teşekkür ediyorum. Benim sorum şu olacaktı. Big Bang'den önce, daha doğrusu Big Bang neyin içinde patladı? İlk patlama neyin içinde oldu? Nasıl bir ortamda? Bir de şunu eklemek istiyorum. Big Bang patladıktan sonra katı cisimler oluştu bizim bildiğimiz. Bu katı cisimler nasıl oluştu?
Right. Well, if the universe had a temporal beginning, then there was no before. And the current evidence is that there was no before. The universe did have a temporal beginning, something like 13.8 billion years ago. And there are a number of theorems that prove that. In fact, Hawking began his life in cosmology, Stephen Hawking, by proving a singularity theorem. He tried to get round it later in life by coming up with what he called the no-boundary proposal, whereby as you track back the history of the universe in time, you get to imaginary time, and you end up in a four-dimensional space which just is, as he put it. The trouble is that if you really think that four-dimensional space is that out of which the present universe emerges, the question is how? Because it's real time you need for change to occur, and we've heard about change as well today. So I don't think that really works as a way of getting round the beginning, and indeed in his more technical papers, Hawking himself seemed to admit that.
Acıbadem Üniversitesi'ne teşekkür ediyoruz. Ev sahipliği yaptı bu büyük organizasyona. Ve tabii daha önemlisi vakfa teşekkür ediyoruz. Vakfın maddi manevi olarak destekleyen arkadaşlarımız var. Onlar olmasa bu organizasyon olmazdı. Yani aylardır bunun üzerine çalışıyorlar. Onun dışında konuklarımıza teşekkür ediyoruz, katılımcılara. Çok güzel bir organizasyondu dediğim gibi ve sizlere teşekkür ediyoruz. Gündeminiz eminim sizin de yoğundur ama vakit ayırdınız, geldiniz. Teşekkürler tekrar. Şimdi konuşmacıları toplu resim ve plaket için sahneye davet ediyorum.
Hocam kapanış konuşması yapacak mısınız?
Yok, başka bir kapanış konuşması yok.
Uluslararası Bilim Felsefe Din Konferansı'nda değerli akademisyenlerimizin sunumlarını izledik. Bizlere eşlik ettiğiniz için tekrar hepinize teşekkür ediyoruz. Şimdi hediye edeceğimiz kitapları da çekilişle belirledik. Bu isimleri de sizlerle paylaşacağım. Kayıt sırasında iletişim bilgilerinizi paylaştıysanız ekip arkadaşlarımız sizlerle iletişime geçecektir. Bir hafta içinde kitaplarınızı kargolayacaklar. Kayıt bilginizi henüz vermediyseniz de danışmadaki ekip arkadaşlarımızla bilgilerinizi paylaşabilirsiniz. Şimdi isimleri sizlerle paylaşıyorum. Emine Aras, Seda Durdağ, Hüseyin Eftal Değer, Merve Nur Altıntaş, Enes Açık, Alper Yıldız, Pusat Denizli, Merve Yıldırım, Burak Pekduran, Esma Hande Seviş isimli katılımcılarımıza bu kitapları, kitap setlerini hediye edeceğiz. Şimdi plaketleri takdim etmek üzere ekip arkadaşlarımızı davet edeceğim. Önce toplu resim alalım. Davet ediyorum. Emre Dorman hocamızı sahneye davet ediyorum. Richard Swinburne'e plaketini takdim etmek üzere. Mehmet Bülgen hocamızı sahneye davet ediyorum. Caner Taslaman hocamıza plaketini ve hediyesini teslim etmek üzere.